Here's Galois question number 1. A prime number is a positive integer greater than 1 whose only positive divisor are 1 and itself. For example, 2 is a prime number since it is greater than 1 and its only positive divisor are 1 and 2. So what is the product of the three smallest prime number? This one is really easy, which is 2 times 3 times 5, which is give us 30. First question answer. Second, there are two integers c with one is between c and 1. C is between 1 and 20, which is c minus 3 over 4 is a prime number. Okay, and we're looking for the integer c. So what we should do here is we'll assume the prime number that we're looking for equal p, and we write expression into c minus 3 over 4 equal p, and move the 4 to the other side. C minus 3 equal 4p, and lastly c equal 4p plus 3. And now we substitute several small prime number to find the value of c. We first substitute 2, so we get 11 for c, and we substitute 3 for p. 4 times 3, 12, 12 plus 3, 15, still smaller than 20, and we try 5. We see 4 times 5 equal 20, 20 plus 3, 23, 23 is bigger than 20. So our solution here is 11 and 15. Okay, last question. So determine all integer d with 1 smaller equal to d smaller equal to 10, for which 21d minus 77 is a prime number. Okay, first, as usual, we simplify the expression first to see what will happen. In most cases, we need to simplify. So this one we see they have a common factor, which is 7, and 3d minus 11. And in order to obtain a prime number, we have to let result be 7 times 1, otherwise it's not a prime number. So, which means we need to get 12 minus 11 to obtain 1. And here 12 should equal to 3 times 4, so d here is 4. And it's the only possibility here. And that's it. D equal 4. Okay, thank you. First question. We're looking for the area of triangle ABC. And we know triangle ABC has vertices A equals 3, 4, B 2, 1, and 6, 1. So this means by observing the y value of the BC, we see it has the same y coordinate, y value for its coordinate, so which means they're on the same line, and its height just 4 minus 1 equals 3. So 6 minus 2 equals 4 for its base, and then 4 times 3 over 2 equals 6. And this is our answer for the area of triangle ABC. Next, point D is the image of point B after it is reflected in the y-axis. What is the area of ADC? Y-axis is this line, and across B this means across y-axis this means which is here. because a reflection line is midpoint between the D and the B, and B right now is +2, so here should be -2. So connecting dots, we see the area of a triangle ABC. Right now, its base is increased by 4. So we just need to add 4 times 3 over 2 plus our last question answer, 6, which is 12 over 2, 12. Something like this. Okay. Question C. Point E is image of A after it is reflected in the horizontal line y equal -2, y -2 here. And what is the area of a triangular EBC? So after reflected over the y equal -2, wait, what's wrong? Y equal -2, A come to down here. Okay. First of all, let me draw a line to see what's happening here. This is A, and this is y equal -2, and this is point E. And these two segments has to be the same, since y equal -2 is the reflection line for A. So what we need to do here is we just need to find the value between A and y equal -2, and then times 2 to find the entire length for this. And then we minus the value of the original height for the triangular ABC, which is 3. And the rest is the height for the triangle EBC. Okay. This means we just need to find -2, absolute value of it, plus 4, we get 6. This part equals 6. And then 6 times 2 to find the differences to find the length between point A and point E, which is 12. 12. We minus the height for the original triangle ABC, which is 3. We get 9. And then we use this 9 to times the base, 4 over 2. And we find our solution for question C, 18. Okay. Question D. Point F is the image of point A after it's reflected in the horizontal line y equal k. Determine the two different values of k for which the area of the triangle FBC is equal to 12. So since the triangle and its base is maintained the same, which is 4, it means 12 equal 4 times something times x over 2 is equal to 12. This means x equal to 6. Okay. And let me draw a graph and the relationship between the A and F and K is like this. This is A. We name this is F1 and name this F2. And the midpoint between A and F2 is K2, and the midpoint between A and F1 is K1. This is 2. Okay. We can see since A point A is reflecting in the horizontal line of y equal k. This part is same as this part, and this part is same as this part. Okay. Based on this, we can do the calculation. Where first we add 6 or minus 6 on the base, which is y coordinate for B or C, which is 1, 1 plus 6, or 1 minus 6. So we say this, the first case 1, the first two cases 2. We first try to see the first case, 1 plus 6. We see we get 1 plus 6 equals 7. So we want our y coordinate equals 7. And this is our F1. F1 equals 7. And right now we're trying to find the K1. So we do 7 minus the value of A, which is 4, equals 3. Right now we find this part. But right now, because since we're now looking for the differences between F1 and A, we're actually looking for the midpoint of it. So we do 3 over 2, find the differences between K1 and A, and then plus A, which is 4. And we find our first answer, 5.5. Okay, second. For the second case, 1 minus 6. Similarly, we get a minus 5. And minus 5 is here. Somehow around here, I guess. Yeah. So to find the value between the F2 and A, we need to, let me wait for a moment, because minus 5 is a y coordinate for F2. We do minus 5, absolute value of it, plus 4, the y coordinate for A, which we get 9, and then 9 over 2 to find the value of K2, which is 4.5. Then 4, because downward, so 4 minus 4.5, we get minus 0.5, and this is our second K value. So we conclude, for the question D, our two answer is 5.5 and minus 0.5. Okay, thank you.